Hello everyone, in this video we'll be talking about the baseband transmission and then we will see the issues with the baseband transmission. After that we will see the definition of the modulation and the types of the modulation, as well as we'll go through the advantages of the modulation, and at the end of this video we'll see the various type of the carrier waves. So let's begin. The purpose of the communication is to transmit the message signal or the information, and the message signal is also known as the baseband signal. The baseband represents the range of the frequencies of the message signal. Got it? And whenever the message signal is directly transmitted through the medium, we call it baseband transmission. For example, you two people are sitting in a park and talking with each other. Then the transmission of the voice is counted as the baseband transmission. Why? Because your voice is directly transmitted to the receiver through the air. Got it? Another familiar example of the baseband transmission is the string phone. You might have tried this in your childhood. Someone is speaking in a cup or a tin can and the other person is listening. What are the issues with this kind of transmission, the baseband transmission? Issues are simple. Number one, the range is limited. Number two, the different noises or the other signals will get mixed up with the original message signal. Got it? So now we will be talking about the three major issues with the baseband transmission of the electronic signals. Number one is the size of the antenna. Number two is the power radiated by the antenna. And number three is the mixing up of signals. Let's see their details one by one. Suppose we have some electronic signal of frequency 20 kilohertz and we want to transmit this signal using the antenna. Then the length of antenna required is n times lambda by 2, where lambda is the wavelength of the signal, n is some positive integer, and L is the length of the linear antenna. Okay, we require lambda for the computation, so I am using the formula C is equal to F lambda. C is the speed of the light, F is the frequency, and lambda is the wavelength. We know all the values, so putting up the data here, 3 into 10 to power 8, frequency is 20 into 10 to power 3, and the lambda is unknown. I am omitting the units here. We are working with the SI system in the entire question. The units I'll write at last. So lambda will come out to be 15 kilometer. Okay. Now, if you put this lambda here, the length of antenna will be n into 15 kilometer divided by 2, which is equal to n into 7.5 kilometer. Making an antenna of such a great length is practically impossible. This n is 1, 2, 3, any positive integer. So we need to use the signals of the higher frequency. Then we can have the antennas of the practical length. For example, I choose another signal having the frequency is equal to 20 megahertz. For that signal, I am obtaining the lambda, which is equal to C by F. C is known to us 3 into 10 to power 8. F is 20 into 10 to power 6. This will give you lambda as 15 meter. If lambda is 15 meter, the length of antenna will be n times lambda by 2, which is equal to n times 15 meter by 2. So this time the length of antenna is small. It is the practical thing. We can easily make antennas of such lengths. Got it? You may note it down, then we'll see the second issue. Let's talk about the second issue. The power radiated by the antenna is proportional to L by lambda whole square or is proportional to L square f square. For a given antenna, the length L is fixed. It means that smaller the wavelength of the signal, the antenna can radiate more power, or higher the frequency of the signal, the antenna can radiate more power. And via modulation, we can increase the frequency of the signal. It means we can radiate more power and then signal can be sent to greater distances. Got it? Directly, if you want to send the signal of low frequency or a greater wavelength, then the antenna cannot radiate efficient amount of power. Okay. The third issue with the baseband transmission of the electronic signals is when we transmit so many signals together, they might get mixed up. Suppose many people are speaking up in a room and then their voice is transmitted through the same channel, through the same medium. What will happen at the receiver end? It will be a mixture of various voice signal and it will be impossible to extract out the different signals from that mixture. Got it? So these are the three major issues with the baseband transmission. To get rid of all these issues of the baseband transmission, we use a special technique known as the modulation. The word modulation means varying some aspect of the carrier signal in accordance with the message signal. We have two types of the carrier signal, the analog signal as well as the digital signal. An analog carrier signal is a high frequency signal. Here CT indicates the strength of the signal, the strength of the carrier. It could be given in the terms of voltage or in the terms of current. AC indicates the amplitude, omega C indicates the angular frequency of the carrier, and phi indicates the initial phase. In modulation, we can change the amplitude of the carrier, we can change the frequency of the carrier, as well as we can change the initial phase of the carrier, and will get the different type of modulations. Similarly, we can use a digital signal or a pulse for the modulation, and we'll get three different types of modulation: the pulse amplitude modulation, the pulse width modulation, and the pulse position modulation. Got it? Okay. Here we can see few advantages of the modulation. Once the signal has been modulated, it can be transmitted to larger distances or the longer range. Clear? The modulated signal can be radiated with more power through an antenna. We get more selectivity and there is no mixing of the signals. These are few important things. You may note it down, and then I'll give you a practical example so you can understand the term modulation very well. Suppose you have to send a kid from your home to the school which is 25 kilometers far away from your home. Consider the kid as a message signal. What modes of transmission of that message signal is possible? How you can send that kid to the school? One is the baseband transmission. Baseband transmission means original signal is directly transmitted to the school. So you put the bag on the shoulders of that kid, you hang down the water bottle and ask that kid to walk towards the school which is 25 kilometers away. Has the signal, has the message sufficient strength to reach to the target position, target point? Not possible. A kid of age 4 years or 5 years cannot travel 25 kilometers by himself or herself. You got it? So baseband transmission of message signal will not work in this case. Then what is the other way possible? You hire a cab. A high speed cab will be known as a carrier. Now you put the message signal on the carrier. You impose the message signal on the carrier. This process at your home, imposing the message signal, making the kid to sit into the cab, is known as the modulation. Now that cab moves with high speed because it has high frequency, high energy, and that cab carries the kid to the school. At the school gate, the cab and the kid are segregated. This is known as the demodulation. The original message signal is sent to the school, the kid is sent to the school, and the carrier is discarded away. That process is demodulation. Got the advantage? Using the modulation, you can send the message signal to a greater distance. Stay awesome. See you again.